Today's flipped lesson, lesson 28, solving multi-step equations. Our content objective for today is that you'll be able to solve multi-step equations by combining like terms. Next flipped lesson, we will deal with the distributive property part. We're also going to discuss how to write equations from word phrases, and then our usual why am I learning this. So a little bit of background knowledge. One of the things we've worked on as of late would be combining like terms. We also call that adding like expressions. When we're doing that, we can only add things together if they have the same variable with the same exponent. So 3x and positive 4x, those are like terms. They simplify to 7x. We have nothing to combine with the 5y, so that simplifies to 7x plus 5y. Next problem is another one that we talked about earlier. We can combine our 4a and our negative 3a. Remember, if you don't understand that that is a negative 3a, add the opposite and you will see that it is a negative 3a. Same thing with the subtracting 2. That's really a negative 2. If we add the opposite there, we will see that. But either way, 4a and negative 3a make 1a or just a, and positive 6 and negative 2 make positive 4. And just like in the regular lesson on this, I always use shapes to highlight the like terms, and also make sure you include the sign in front. So the second one simplifies to a plus 4. And then we've worked in full detail yesterday on how to solve two-step equations. We always want to deal with the adding or subtracting part first, and then we deal with the multiplying or dividing part. And from there, if, as in this problem, if it's not evenly divisible, then off to the side we're going to have to do some long division. So here we have 29 divided by 4. 4 goes into 29 7 times with a remainder of 1, and that is where we get the solution of W equals 7 1/4. Solving equations by combining like terms. Here's a typical equation where we would have to do that. 4x minus 2x plus 7 equals 19. The first thing that we want to do, if we can, is to combine like terms. And as you can see in this equation, we have a positive 4x and a negative 2x. And once again, if you don't understand that that is a negative 2x, let's add the opposite, and you can see that that is truly a negative 2x. So 4x, positive 4x, and negative 2x make 2x. And so this simplifies to 2x plus 7 equals 19, which is now a regular two-step equation. In a two-step equation, always deal with the adding or subtracting part first. The inverse operation to adding 7 is subtracting 7. Or remember, we had a couple of ways to check that. One way was making sure that these two things were opposites of each other. And they are. Or the other way of looking at it is with the additive inverse property on making sure that these two things have a sum of 0. And once again, they do. So positive 7 and negative 7 make 0. We're now left with a one-step equation. 2x equals 12. The inverse operation to multiplying by 2 is to divide by 2. And we do that, and we get a solution of x equals 6. All right, number 1. Pause this video, and you try number 1. All right, let's take a look at number 1. In number 1, if you can combine like terms, you should. And we can, because we have a positive 5x and a negative 2x. That makes 3x, positive 3x. So the original equation simplifies to 3x plus 6 equals 21. We now have a regular two-step equation. Let's subtract 6 from both sides. We always deal with the adding or subtracting part first. We have made 0 right here. So we can move on. That leaves us with 3x equals 15. The inverse operation to multiplying by 3 is to divide by 3. And our solution is x equals 5. Pause this video and try number 2. Let's take a look at number 2. We have like terms of 6x and negative x. Now remember, anytime we have a variable without a number in front, there really is a number in front, and that number is 1. We just don't typically write it. So let's go ahead and put a 1 in front of that x. And now let's combine our positive 6x with our negative 1x. That simplifies to 5x. And so our equation turns into 5x minus 7 equals 18. We now need to do the inverse operation to subtract it, subtraction by 7, which is right here. And that, of course, would be adding 7 to both sides. The check is making sure, once again, that these two things are opposites, or in other words, that they make 0, and they do. So we have 5x equals 25, divide both sides by 5, that is the inverse operation to multiplying by 5, and our solution is x equals 5. Let's take a look at number 3. Pause this video and try number 3. Let's take a look at number 3. In the first couple of equations, the variables were on the left-hand side. In both of these that you're about to do, the variable is on the right-hand side. Remember, we talked a little bit last time that it's okay if you don't like the way this equation looks, you could rewrite it like this instead. It would be okay to do that if you feel more comfortable with the variable being on the left-hand side. But you don't have to. You're going to end up with the same solution no matter which way that you do it. I'm going to leave it the way that it is. I will put a 1 in front of the y. I will combine my y's together, my like terms. That simplifies to 1y, or just y. So I have 14 equals y plus 8. And now we just have a one-step equation. Subtract 8 from both sides. Remember, the check is making sure we're doing the inverse operation, or making sure that those two things are opposites or make 0, and they do. So y is equal to 14 minus 8, which is 6. The solution is y equals 6. Pause this video and try number 4. All right, let's take a look at number 4. Like in number 3, if you don't feel comfortable with the variable being on the right-hand side, we could rewrite this to look like this. 5m minus 2m plus 4 equals 19. If that makes you feel a little more comfortable, it's okay to do that. I'm going to leave it the way that it is and solve from there. I'm going to combine my like terms. A positive 5m and a negative 2m make a positive 3m, so this simplifies to 19 equals 3m plus 4. Now we have a two-step equation. Subtract 4 from both sides. Remember, once again, we always deal with the adding or subtracting part first. We've made our 0 right here, or these two things are opposites of each other. That's the check, and they are. And that would simplify to 15 equals 3m. The inverse operation to multiplying by 3 is dividing by 3, and we end up with m equals 5. So the solution is m equals 5. Next time, we will deal with equations that involve the distributive part.